The Sandakan District Mosque was first planned for construction by laying the foundation stone on 20 February 1981 by YB Tan Sri Tengku Razali Hamzah, who was also the finance minister at that time. And on 11 October 1982, the Sabah government began to search a suitable site for construction of the Sandakan District Mosque, and on 23rd September 1985, the construction project of the Sandakan District Mosque was commenced. The mosque was designed by an architect of Jurubina Bertiga International Partnership, which is Datuk Dr. Haji Baharudin Abu Kasim. After about 4 years of construction process, the Sandakan District Mosque was finally completed in December 1989 and was inaugurated on 27 July 1990, the same day as Friday. The most notable features of the mosque is tapered pyramidal roof, which is somewhat reminiscent of a vernacular mosque design of the region. The pyramidal structure site on 8 sides Islamic geometrical pattern base plane and is distinctively topped with a pointed dome finished in concrete with zigzag patterns and copper crescent pinnacle. The main entrance staircase is placed on one of these 8 sides. Additional architectural features are the slender minaret and a customized water tank structure that gives a sense of unity of the entire mosque. The zigzag patterns on the exterior of the dome are replicated on the interior surface of the pyramidal roof, creating continuity between inside and the outside. Besides the zigzag pattern timber ceiling, the other timber elements in the mosque are the mihrab and the elevated platform mimbar, which are probably the only features of the mosque that are more traditional in their design.
Furthermore, the location of this mosque is very strategic because it is located along Jalan Buli Sim Sim, close to the pillar village of Kampung Buli Sim Sim. The Sandakan District Mosque can cater for up to 7,000 worshippers at any one time, and was built with the intention and purpose to provide facilities, especially for Muslims around Sandakan to carry out their act of worship such as 5-hour prayers, Friday prayers, Hari Raya Aidil Fitri prayers, Hari Raya Aidil Adha prayers, and also religious activities. Others, with the construction of this mosque, it is also a good sign because the mosque is a place and unification of the Muslim community in all matters of life, whether related to worldly or ukhrawi matters.
There are 4 geometrical shapes that applies on the mosque. For 2-dimensional shape, it involves the rectangle, parallelogram, and triangle. For the 3-dimensional shape, it involves the trapezoid. Now, let's move on to the next one, which is the concept of the geometrical object towards the mosque. The mosque consists of rectangle, parallelogram, triangle, and trapezoid as their main design. The parallelogram shape appears on the mosque as the windows and connected to the trapezoid that act as the roof. Now, let's take a look to the geometry shape one by one, shall we? Okay, so first geometry shape is rectangle. From the picture, we can see that the rectangle geometry shape can be found on the roof of the mosque. So in a rectangle, we know that a rectangle is a parallelogram that has the right angle. All the angles of a rectangle are right angles. The opposite sides are parallel and equal to each other. the diagonals of a rectangle are congruent. The diagonals bisect each other, and the last one is both the diagonals have the same length. The sum of the interior angle of rectangle. So from the picture, we can see that rectangle has four angles, which is the A, the B, the C, and the D. So each interior angle is equal to 90 degrees. So we can say that angles A are equal to angles B, are equal to angle C, and are equal to angles D. And we can say that all the four angles are congruent angles. So angles A plus angles B plus angles C plus angles D are equal to 360 degrees. So how to find the perimeter of rectangle? So from the picture, we can say that X is the width and the Y is the length. So the formula of perimeter of rectangle is equal to 2x plus 2y. So using the exact measurement of the moss, we can say that x is equal to 80 meter and y is equal to 120 meter. So the perimeter is 2 multiplied by 80 plus 2 multiplied by 120, and we will get 400 meter for the perimeter of rectangle. Next, let's move on to the area of rectangle. So the formula of area of rectangle is x multiplied by y. So we insert the measurement, we will get 80 multiplied by 120, and we will get 9,600 meters square. Okay, the next shape is the parallelogram. From this picture, we can see the parallelogram shape appear on the window of the mosque. Okay, so based on this picture, we can say that the diagonal of a parallelogram separates it into two congruent triangles. The opposite angles of a parallelogram are congruent. The diagonals of a parallelogram bisect each other. And the last one is two consecutive angles of a parallelogram are supplementary. Okay, so the sum of the interior angles of parallelogram, we can see that angles A plus angles B are equal to 180 degrees. Angles A plus angles D are equal to 180 degrees. Angles D plus angles C are equal to 180 degrees. And angles C plus angles B are equal to 180 degrees. From the picture also, we can say that angles of ABD are equal to angles of BDC, and angles of ADB are equal to angles DBC. And the last one is angles BAD are equal to angles DCB. And we can say that the triangles of ABD are equal to the triangles of DBC. Okay, how to obtain the perimeter of parallelogram? Okay, from the picture, we can say that DA is the length of A, line AB is, we call it as base, and the height we say as altitude, H. So how to obtain the perimeter? The formula is 2 multiplied by A plus B. So if we insert the exact measurement, which are altitude is 6 meter, side is 9 meter, and base is 20 meter, we can conclude that 2 multiplied to 9 plus 20, we will get 58 meter. And how to obtain the area of parallelogram? The formula is area equal to base multiplied by altitude. So from the measurement, we can say that 20 multiplied by 6, and we will get 120 meters square.
Isosceles triangle. Isosceles triangle are those triangles that have at least two sides of equal measure. The two equal sides of an isosceles triangle are called the legs, and the angle between them is called the vertex angle or apex angle. The side opposite the vertex angle is called the base, and base angle are equal. The sum of interior angle of an isosceles triangle is 180 degrees. We can find the perimeter of an isosceles triangle by adding all the sides length. So for this triangle, we just add 64 plus 64 plus 50 meter, and we get the perimeter of the isosceles triangle is 178 meter. We can find the area of an isosceles triangle by using the formula 1 over 2 times B times H, which is B is the base of the isosceles triangle and H is its is its height. We just substitute 50 of its base and 40 of its heights, and we get the area of the isosceles triangle is 1000 meters square. Trapezoid. An isosceles trapezoid is a trapezoid with congruent base angle and congruent non-parallel side. If two opposite sides of the trapezoid are parallel and the two non-parallel sides are equal in length, then it is an isosceles trapezoid. A trapezoid is a quadrilateral with only one of its sides is parallel. The base angle of the trapezoid are the same. The sum of opposite angle is 180 degree or supplementary angle. For example, by adding angle DAB and angle BCD, we get 180 degree. Same goes to when we add angle ABC and angle ADC. We can find the perimeter of a trapezoid. We add all the sides length. So for this trapezoid, we just add 110 plus 110 plus 80 plus 150, and we get the perimeter of this trapezoid is 550 meters. The formula to find the area of a trapezoid is sum of parallel sides divided by 2 times its height. So by substituting the sum of the parallel side lengths, we divide it by 2 times the height, which is 100, and we get the area is 11,500 meters square. Truncated rectangular pyramid. Truncated rectangular pyramid consists of 2 rectangles as its base and top, and 4 trapezoids on its sides. A truncated pyramid is the result of cutting a pyramid by a plane parallel to the base and separating the part containing the apex. The lateral face of a truncated pyramid is made of a trapezoid. We can find the volume of a truncated rectangular pyramid by using this formula. So we get the volume of this truncated rectangular pyramid is 2.14 million meter cubes, and this is the formula to find the lateral area of a truncated rectangular pyramid. So we get the lateral area is 57,211.97 meters squared. So to find the total area of a truncated rectangular pyramid, we just add the lateral area plus the area of the 2 rectangles. So we get the total surface area is 95,311.97 meters squared.
There are a lot of motifs and patterns that can be found around this mosque. We found an interesting pattern inside the mosque that go through the process of transformation. The first transformation is the reflection of an irregular hexagon, and second is the rotation of an irregular hexagon. We can find this pattern inside this mosque on the carpet.
Based on the task given in the second assignment of the SMG3013 geometry course, we have investigated the characters and information about objects with various types of shapes and how to measure each of them. We had chosen one of the mosques in the Sabah as our object for investigating its details and the information for our study. While for part B, we already focused on the shape of the mosque. Then, we already found how to relate all the shapes that can be seen in the objects, which is the mosque, with their theory and the relationship between the measurement of the object, and also relate all the shapes with their concept of geometry. For example, we can see more than one shape that has been created to build the mosque, such as parallelogram, triangle, rectangle, and trapezoid. And we know there are more shapes that we might not know existed shape. Furthermore, we also investigated how to relate motifs and patterns on the object with their concept of transformation. For the conclusion of this task, we must know that everything that exists in our surroundings always has its shape. As future teachers, we need to understand that every shape on the object has its theory, measurement, and concept. We need to understand all the information related to each shape, and it is also essential to know how to measure and apply the concept in each shape. After performing all these tasks, all of us are willing to apply all the learning outcomes regarding to the shape in our culture that we might find in our future with their measurement, concepts, patterns, and others.